Hey physics peeps, so we're going to go over the Unit 2 test on free fall. You only have one question two questions that you need to answer. And it's going to look something like this. A quarter is flipped straight up in the air next to a high cliff at a speed of 20 meters per second. What is the speed of the quarter after 2.5 seconds? And how far away is the quarter from where it started? So, to answer these two questions, first we got to kind of picture what's going on. So we have this quarter. That's flipped straight up in the air at 20 meters per second. That's like a speed it's starting at. In fact, we call it the initial speed. And as that quarter goes up in the air, flips, but as it goes up, it's kind of slowing down. Slows down, slows down, slows down, and then it starts coming back down. But to answer these questions, to figure out what speed it's going after 2.5 seconds and how far away, well, there's some key words here. Speed. They're looking for a speed after a certain amount of time. They're really looking for a final speed. And when they say how far away is the quarter, they're really looking for a distance. So these are two things that we got to solve. And there's two equations that we can use for these. And those are these. VF equals VI plus A times T. And D equals VI times T plus 1/2 times A times T squared. A couple things about using these equations. The F stands for final, I stands for initial, the A stands for acceleration, T stands for time. Make sure you don't mix up the T and the plus here because they look similar, but the T is time, this is the plus, and then you can't forget this square when you use that equation to solve for distance. So we're going to use those equations and solve this out. And what's the speed of the quarter after 2.5 seconds? We can use this equation to solve that out because we're solving for the final speed. VF equals VI plus A times T. We put stuff in where it belongs. The initial speed is what it started at. It started at 20 meters per second. Plus the acceleration. As this is going up in the air, gravity is trying to pull it back down. And that's the acceleration. The acceleration comes from gravity, and it's negative 9.8 meters per second squared. It's negative because gravity pulls down. Times the time. The time they're asking for is after 2.5 seconds. So we put that into our equation, 2.5 seconds. And now we just have all our information in. We can solve for this final velocity by doing our math. But keep in mind you gotta do orders of operations. You have two things here, addition and multiplication. You have to do multiplying first and then you'll do the addition. So you gotta take this negative 9.8 times 2.5 first. So I'm gonna do that on my calculator. 9.8 negative times 2.5, and I get this showing up on my calculator. Negative 24.5. And now I add 20. When I do that, I get this for my answer, negative 4.5. Couple things about this. This is our final speed, but units, you have to have a unit here, and it's the speed that we solve for, so it's meters per second. And our answer is negative, which means that it's going down after seconds. There's points when it might be positive, and it would be going back up. So that's kind of where we get our answer, negative 4.5 meters per second. That's that part. And now we're going to solve for the distance. is how far away is the quarter from where it started. That we can use the second equation. And this D equals VI times T plus 1/2 times A times T squared. There's two parts to this equation. It's kind of like it has a first part and a second part. And you do your multiplication first and then you do your addition. But you start putting in your information first. So we're solving for the distance. We need to know the initial speed. It still started at 20 meters per second. That's the same thing. Times the time. Well, we're still talking about after 2.5 seconds. So that's the time that goes in. That's our first part. Plus 1/2 times the acceleration. The acceleration is still the same. It's from gravity. It's pulling down at negative 9.8 meters per second squared times the time. And it's still 2.5 seconds. However, this 2.5 seconds, this has to be squared. And so that has to be squared in that equation. You can't forget the square. So now we're going to do our math. Once we have everything filled in, we do our math. So this side we can do 20 times 2.5. You can do that in your head. But if I do that, I get this. I just get 50. Plus, when I do this part, I got to make sure I do my orders of operations. And I'm doing multiplying, but I also have this squared. You have to do the squared. It's kind of like taking 2.5 times 2.5. It is just like doing that. Times negative 9.8, you have to make sure it's negative because gravity's pulling down. Times 1/2. If you want to put on your calculator 0.5, that's fine. You could do that. So if I do that, 0.5 times negative 9.8 times 2.5 times 2.5, I end up with this. 30.625. Negative 30.625. And now that I have these two parts, I can add them together. If I do that, I get this. 19.375. That's my distance. And notice that I need a unit for distance. It's meters. And so these are my two answers, and that's how I get them. Just make sure that you're putting things in where they belong. Put your initial speed in, your acceleration, it's negative 9.8 for here on Earth. And then your time, just kind of watch what time that they're asking for. And that's kind of it. Don't forget the square. Make sure you do orders of operations. You should be good. All right. See you guys.